Welcome back. In the previous video, we learned some of the most important Dockerfile instructions like work directory, CMD, and entry point. Today, we will solve a very real-world problem: data loss inside containers. Containers are ephemeral, which means temporary. If a container is deleted, everything inside it is gone forever. Imagine storing important data like customer records and suddenly losing it. Scary, right? Don't worry. Docker has a solution. With volumes, you can keep your data safe even when containers are deleted. By the end of this demo, you will know exactly why volumes are needed and how to use them confidently. Let's get started. I am here in Visual Studio Code. I have already created a folder for today's demo. Let's check the Docker file. I am using Alpine as base image from Alpine 3.20. Alpine is a very lightweight Linux distribution. 3.20 is the version number. And work directory instruction, it creates /app folder inside the container if it doesn't exist and sets /app as the default working directory. CMD instruction, sh-c. This runs a series of commands in a shell. Echo, create a file /app/message.txt with the text hello from container, and this logical AND operator run the next command only if the previous succeeded. Cat command to display the file contents. Sleep command, sleep 300, keep container alive for 5 minutes so we can explore it. Let's build the Docker image. Docker build -t. I am giving the name as message demo dot. Let's check Docker images. So message demo created. Let's check Docker Desktop. Message demo created with latest tag. Let me clear the screen. Docker images. Let's do Docker run. Docker run -d detach mode --name. I'm giving the name as my message container, and we need to pass the image name, message demo. Let's check Docker ps. So the container is up and running. So what happens internally here? The container starts and /app/message.txt is created and message printed to container logs. Container stays alive for 5 minutes. Let's view the logs. So the command is docker logs. We need to pass the container name. Hello from container. Let's explore inside the container. Docker exec -it. We need to pass the container name and sh. Now we are inside the container. Do ls and let's verify the contents of the file. Hello from container. So we viewed the logs, also verified the contents of the file inside the container. Let's exit the container. Let's try deleting the container. Docker rm-f, pass the container name, docker ps-a. The container got deleted. Let me clear the screen. Docker ps-a. The container got deleted, and let's try accessing the file again. Docker exec iMessage container. Let's do cat command /app/message.txt. There's an error here. No such container, my message container. Why? The file was stored in the container's writable layer. When the container was deleted, that layer disappeared, and so our data also disappeared. Meaning, when we delete the container, we lost the data as well. How to fix this problem? We can fix this with a named volume. Let's do docker run again. Docker run -d detach mode -name. I am giving the same name, my message container, and -v flag we need to specify in order to specify the volume name, and my_volume is the volume name I am giving here. /app is the path inside the container, and we need to give the image name. Let's copy it. Docker ps. The container is up and running. Here -v is the flag we need to specify, and my_volume is the name of the volume. Docker creates it automatically if it doesn't exist. Think of it like a USB drive labeled as my_volume, and /app is the path inside container, the folder inside the container where volume is mounted. Now /app is connected to the volume. Any files written to /app are stored outside the container, safe and persistent. Let's verify in Docker Desktop. Go to volumes tab here. See, my_volume is listed. Go to containers tab. The container is running. Let's go to volumes tab again and click on my_volume. You can see message.txt under stored data, and this my_volume in use. Click on container in use. You see the container name, my message container is using my_volume. Let's try deleting the container. Docker rm-f, pass the container name. The container got deleted. Check if the data persisted or not. Let's do docker run -v volume and pass the volume name my_volume colon the path inside container /app, and I'm giving alpine as the helper container, and let's check cat command /app/message.txt. See, hello from container. Even though the container is gone, the file remains safe in the volume. Let's try running the command again. Hello from container. Let's try again. Hello from container. Let me clear the screen. Let's check docker ps-a. See, we have the status of the containers as exited. So after printing the contents of the file, the container exited. But if we run this command like multiple times, so whenever we do the docker run, it will create the new container and then it will print the contents of the file, and after that the status is exited. Docker keeps the helper container in a stopped state. If you do this repeatedly, you will end up with lots of clutter. So we need to remove manually by using docker rm command. But there is a flag --rm to do the auto cleanup. Let's try deleting the containers first. Docker rm -f. Okay, let's check. So the containers got deleted. Let me clear the screen. Let's try running the same command again, but with rm flag -rm. So it printed the contents of the file. Let's try one more time. Let's try one more time again. Let's check docker ps-a. See, so here with -rm, the auto cleanup flag, the output, you see nothing here. So with -rm, Docker automatically deletes the helper container when it exits. The volume and its data remain safe. Only the helper container is removed. We can check the Docker desktop quickly. See the volumes here. My_volume is safe. Let's go back. Let's try creating and inputting some data here. Let me create empty volume. Docker volume create. This is the command, and let's give the name shared_data. I'm giving the name as shared_data here. Let's check docker volume ls. So we have shared_data volume got created. This is like a brand new empty notebook. So let's seed some data, meaning let's initialize the volume with some data. Docker run -rm -v for the volume flag, shared_data, that is the name we have given, and that's the name we want to pass. and I'm giving the path as /data, the path inside the container, and let's do alpine, and we'll run some series of commands. sh-c, let's give some echo statement. Welcome, this file was added before any app container started, and we will pass it to the file. So here --rm automatically clean up this temporary container. -v shared data :/data, mount the volume at /data, echo create nodes.txt inside the volume. Let's verify seeded data. Docker run -rm -v, and the volume name shared_data :/data, the path inside the container, and alpine, let's give ls-l /data. See, we have nodes.txt present, and let's try again. Docker run -rm flag -v shared_data :/data alpine, and let's do cat command to view the contents of the file /data/ nodes.txt. Welcome, this file was added before any app container started. So we see the data inside the volume. Let's inspect volume details. Let's go to Docker Desktop. So we have my_volume and shared_data in the volumes tab, and so under shared_data we see nodes.txt as stored data. Let's try without an rm flag once. Let me clear the screen. Docker ps-a. I would like to show you the containers tab as well. So let's try the command without rm flag once, so that we'll have the container without exiting. Docker ps-a. So we have the container, but the status is exited. Let's go to Docker Desktop again. I would like to show you something here. So containers, so it gave some random name here, but if you click on this container, so you can see the logs here as well. So either through commands you can do docker logs, or otherwise you can verify under the Docker Desktop under logs tab here. Welcome, this file was added before any app container started, and we can inspect here. Click on the inspect. Let's search for volume. View the mounts section here. Type volume, name shared_data. So we can see the mounted volumes for a container. Let's do visual recap. A container is like a temporary box. So whatever you put inside the box stays there only while the box exists. So when the container gets deleted, everything inside vanishes. Containers are ephemeral by default, meaning containers are temporary. When you delete the container, data is gone. Volumes are like external storage. So data stays safe even if container deleted. Volumes persist data outside the container lifecycle, meaning volumes keep your data independent of containers. Today we learned that containers are ephemeral and data inside them disappears when deleted. Volumes solve this by keeping data safe and persistent outside the container lifecycle. We also explored how to check data using helper containers, how to auto clean with RM flag, and how to seed volumes with initial data. In the next video, we will dive into bind mounts and anonymous volumes, which is perfect for developers who want to edit files in real time while the container is running, especially during development. Thanks for watching. If this demo helped you, don't forget to share it with others and subscribe to stay updated with more tutorials. See you in the next video.